Hi, 8th grade parents and students. Now we're in lesson 7.5, lesson 5 of module 7, examine special systems. So you've been looking at different systems of equations and how to solve them. Now you're going to look at some different types of systems that um, have different solutions possibly. So the I can statement says I can identify the number of solutions to a system of linear equations in any form. So let's look at the Spark Your Learning. It says, what values would give you no solutions to the system of equations? How do you know? So if you look at both of these equations, they're both written in the slope-intercept form. And remember, the slope is here as the coefficient to x, and then the y-intercept is this next whole number or rational number there. So if you remember, let's just write that out. Y equals mx plus b is that slope-intercept form where this is the slope and this is the y-intercept. So you can see those numbers here. And they're asking you what values would go here and here to make this a system with no solution. So think about that, work on that, pause the video and take a few minutes, and then look at this turn and talk afterwards. What values would make this system of equations have an infinite number of solutions? So that's a little bit different question, so think about that as well. So take a few minutes, look at that, and then we'll go on to the build understanding. So now if we look at the build and understanding, it says, just as when solving a linear equation, the solution set for a system of two linear equations can have one solution, no solution, or infinitely many solutions. So that was actually way back in Module 3 that you looked at those different types of possible solutions. And so now you're going to be looking at it for two linear equations. And they tell you that if two equations have no solution, it means that the graphs of the two lines never intersect because the lines are parallel. So that's really important. One of the things that you've learned is that most of the time you have lines that intersect, but if they don't intersect, it's because those lines are parallel. And that's important for this lesson especially. So let's look, keep going. It says on a map, so here's the map they're looking at. A street that runs in a straight line can be represented by a linear equation, and they've given you some equations, one here, this is for pine, this is for oak, this is for south birch, and then this part up here is for north birch, but you can see birch is just one line. So they say solve the system of equations represented by Oak Street and Pine Street. So here are those two equations. So those are actually written in different forms, you can see. But they want you to solve those system of equations. So you're going to have to do a little bit of reworking of the equations so that you can either use the methods, elimination method or the substitution method that you've learned. And then they say, what was your result? What does it tell you about the number of solutions to the system? One thing that you can kind of think about from what they tell you up here and just looking at those lines, what do you think might happen, and then see if when you solve it that actually happens. What are the slopes of the two streets and what are the y-intercepts? So you may want to change, because this is in the slope-intercept form, easy to see the slope and the y-intercept, change this equation maybe to that same form, and it'll be able to see the slope and then y-intercept more easily. So now if we keep going, you might want to pause there, do number 1 or that portion of number 1, and then go here. But if you want to keep going, and then we can look at D, E, and F, and then you can pause after that, but it's up to you. For this next part, a system of two linear equations has infinitely many solutions if the graphs of the two lines are concurrent and therefore intersect at infinitely many points. So let's look at that. Let's highlight that as well. So there are infinitely many solutions if the graphs of the two lines are concurrent and therefore intersect at infinitely many points. Basically means it's the same line, right? And so they kind of will ask you, now they're going to ask you some questions here in D about South Birch and North Birch. So like we kind of mentioned, that's really all one street, but in this part of town, it's South Birch, and this part of town, it's called North Birch. So they want you to solve that system of equations. So here's one equation, here's another one. And again, this one is already in the slope-intercept form. This one you may need to change so that it is in the slope-intercept form, just to make it a little more consistent and see things a little more easily. So they ask you in E, after you've solved that system, what was the result? What does this tell you about the number of solutions to the system? F, what are the slopes of the two streets, and the y-intercepts? So again, work on that, pause the video, and get those finished, and then we'll go on to the next page. So here in the Step It Out, numbers 2, 3, and 4, they give you more practice working with different systems of equations. And let's look at number 2. So it says this system here, these two equations, has infinitely many solutions. So they tell you that right up front. They want you to graph the system on your own paper. What do you notice? What do you notice about the pair of equations? So if you look at these equations, what do you notice that's similar? What's different? Look at the coefficients here, the whole number here, and just the different things that might be some things in common. C, fill in the blanks to use the elimination method to solve the system. So they give you the type of method they want you to use to solve. How does the final equation relate to the system having infinitely many solutions? So they tell you it has that, but then once you get your solution, you should be able to go back to the build understanding that you just looked at with those highlighted sections and see what that has to do with what they told you previously. Then number 3, they give you another system and they tell you it has no solution. They want you to, again, graph that on your own paper in A. What do you notice? What do you notice about the pair of equations? So look at here again, look at the coefficients each time and the answer there, 3 and 8. What do they have in common? Do you notice any common factors? There are no common factors, just everything that you might notice that might make you recognize when a system has no solution before you even solve. And then C, fill in the blanks. This time they want you to solve by substitution, but they're going to help you go step by step, so fill in those blanks. And then D, how does the final equation relate to the system having no solutions? Again, you can go back to the previous page, build understanding, and look at what they told you about systems that have no solutions, and if this kind of follows that same pattern and matches up, so you can recognize that later. And then this turn and talk, if you solve the equation in task 3 for y, what equations do you get? How is that related to the graph of the two lines? So look at what you've done and think about that. Then in number 4, again, they're just giving you more practice. That now they're asking how many solutions does each system have? So here's a system, and then actually they're asking you about this one as well, B, couple more systems, and they give you kind of a format step by step to go through. This equation can be simplified by a factor of something, resulting in a new equation that's equivalent. And then this one can be simplified by a factor of something, resulting in a new equation as well. So they're asking you to divide the whole equation by a common factor. 6, 8, and 20, what's a common factor? 9, 12, and 30, what is a common factor? What happens when you simplify those equations by those factors and get those new equations? And then you can answer this question. And then B is similar. They give you some step-by-step. All terms in this equation can be divided by the same factor, resulting in this new equation. And then is this expression equal, and can you then solve this, and then you'll be able to figure out how many solutions that has. So go ahead and pause the video here, work on those 2, 3, 4, those problems, and then you can go ahead and go, if you feel good about it, go on to the check understanding. Once you've completed the check understanding and you feel confident that you understand and or have got this lesson pretty well down, go ahead and work on the on your own. And then after you've completed the on your own and you feel like you don't need any more review, this is optional, so you don't need to worry about that unless you want to try a few more problems. And then do the test prep and the spiral review, and you're finished with lesson 5 and you can go on to lesson 6.